Assalamu alaikum students. I hope you have learnt the previous methods by watching the previous videos of integral equations. Right now we are doing chapter number 4 and we are going to do question, that is, we have to show that integral equation possesses no solution when you have this non-homogeneous part f of x equals to x and has infinite solution when your f of x is 1. And your given integral equation is y of x equals to f of x plus 1 over pi integration from 0 to 2 pi sine of x plus t y of t dt. So let's do its solution. First of all, I'm going to just write this sine of xt. I'm going to expand it using the trigonometric identity. Sine of x cos of t plus cos of x sine of t. I have used here trigonometric identity. And we can see that this is now separable or degenerate kernel. So what we have to do after that? After that, we have to split this integral into these two portions. First of all, we have to write this integration with sine x cos t, y of t dt plus the same integral 0 to 2 pi cos of x sine of t, y of t dt. After writing it separately with these two functions, I am going to take, you know that integration is depending on t. So keep the t inside the integration and take the variables that are depending on x outside the integral. So I got sine of x pi integration 0 to 2 pi cos of t y of t dt. And I took that integral equals to c1 plus cos of x over pi, and here comes the integration 0 to 2 pi sine of t y of t dt, and then I took it as c2. Now I'm going to do two cases, first for x and the second for 1. So the case 1 is when your f of x is x, and you know that the c1 was integration from 0 to 2 pi cos of t y of t dt, and your c2 was this. Now I'm going to solve the c1 first. c1 equals to integration from 0 to 2 pi cos of t y of t. I want to plug in the value of y of t here. I have y of x. So let's take y of t as t plus sine of t over pi c1 plus cos of t over pi c2. Plug in here. After plugging in here, just multiply cos of t with every term and integrate every term separately. You have 3 terms here. They are adding up. After integrating them separately, apply the limits of integration. So you will get here 0 plus c2. After solving this integral, you will get this c1 as c2, or c1 minus c2 is 0. Now let's consider this c2 now and plug in here the yt, value of y of t from this equation. After plugging in here the value and integrate it. And after integration, you will get this equation. And you can see that here we will get c1 minus c2 is 2 pi. And you know that c1 minus c2 is 0. So if you will use the 0 here, you know that 2 pi can never be 0. So it means for f of x equals to x, you have no solution. Now let's take f of x as 1. Plug in here f of x as 1. After plugging in here 1, we'll get this equation. Use this in c1, use the value of y of t here, integrate it, get this equation. Take the c2, plug in the value of y of t here and get it value. After getting these two equations, you can see they both are same. c1 is depending on c2. So we have infinite many solutions for f of x equals to 1. Because we can take any of them as arbitrary and get the value of other one. So we have infinite many solutions. After this example, in the next lecture, we will just solve this integral equation and we will discuss all the cases. So this next lecture is very important. So you must keep watching my channel so that you may be updated when I am going to upload this video.